Hey there, my name's Rashay Gupta, and I'm going to talk about my process of building a soft robot. Alright, to start forth, you might be asking yourself what is a soft robot and how is it different than a regular one. So specifically the robots I'm focusing on are inflatable soft robots. These are robots that are powered through pneumatic pressure and are made through very accessible, easy to get parts, unlike their metal clunky counterparts. So you may be asking now, what are the benefits of using these inflatable soft robots? And specifically the benefits come down to cost, human interface, and general ease of use. First off, when it comes to cost, as I said before, the materials are easily accessible. When it came to building mine, and I'll show it a little later, it came down to household parts, even like a Ziploc container, some plastic tubing, an air compressor, and this is very different than getting very specified pieces of screws and specific pieces of hardware. I use an Arduino for mines, but in general that comes down to a more simple system compared to one that uses a more sophisticated logical computer, etc. Human interface. Soft robots are known for their use as cobots or companion bots next to humans. They can work alongside of humans. When you're in a car factory and you see Tesla creating these cars, the big arms are moving around and you can't really have that. And soft robots also allow for very precise kinematic movements. So that's also a plus. And when it comes to ease of use, none of the movements in the inflatable soft robot are actually hard-coded. So if you're able to use an inflatable soft robot for a search and rescue situation, which is what they're primarily used for, you're not actually in the need to hard code a certain algorithm or neural network to avoid obstacles. It'll do it itself based on its inflating power. So I'll show you the robot right now. Hey. So this is the robot, and it looks really complicated, but I'll be breaking it down into its mechanical and electrical parts. So to start for, this is the Ziploc container I was talking about. There's a motor housed, if you'll focus. So there's a motor housed right in there that's connected to a spool and then the spool is, so the plastic tubing is wrapped around the spool, which is outfed through the PVC out pipe. And then I have a bunch of electronics here controlling the motor. So I'll put that down. So I guess just to talk about it, so at least some of the specs of the robot is it's a 12-volt motor, regular Arduino Uno, 2 5-volt relays, a 9-volt battery, and a potentiometer, Ziploc container, PVC piping, and then some 3D printed parts. There were a couple CAD files I could put that in the description, in case you want to build one yourself. But at least in terms of the electrical components, it's composed of a reverse polarity circuit. And essentially how this works is you have 2 relays, and so in this case those 2 relays, and these 2 relays essentially what they do is they take in one side from the 9-volt battery. The 9-volt battery is what powers the 12-volt motor, but each relay takes in the positive and negative terminal of the 9-volt battery and switches it on and off through a series of normally open and normally closed gates. And that's all controlled electronically through the Arduino. And then I essentially use the potentiometer to create an on-off-on switch where through a certain threshold, the potentiometer is on, or the motor is on in the clockwise direction. On another threshold, the motor is off, and at the third threshold, the motor is reversed. So essentially, you're able to control whether the motor's on, or the motor is clockwise, off, or counterclockwise, and that's able to reverse and I guess make the robot go forward. And I just cut up an old bike tubing. That's how simple the components are. I just cut up an old bike tubing to make the valve for the actual air to go in. So I'll put up a photo of what the robot looks like when it's inflated. But in general, that comes down to the mechanical parts. I mean, that comes down to the electrical parts. When it comes down to the mechanical parts, I had a little bit more of a struggle there. When it came to the 3D printed stuff, actually the files weren't right, so I actually had to cut the 3D prints after they were 3D printed because I was having a hard time getting it 3D printed again. So that took a lot, but eventually, I was able to see the component, and now it's working. It's spooling and unspooling. Some minor flaws that I still have is it doesn't really inflate nearly as well as I want it to. Sometimes I have to pull it out, and if you obviously think this is in a search and rescue position, you wouldn't really have someone in the front of the tube trying to pull it out. You want it to do it by itself. But in general, when it comes down to the cost of all of these components, while I had to buy some repeat components because some broke, but in general, this came down to be really cheap. Only like 20-ish bucks, costs included. I mean, you do have to buy 2,000 feet of poly tubing just to get 8 feet, which is kind of funny, but, when it comes down to 8 feet, it's like a cent. So, I mean, other than that, I think I learned a lot by building this. There's still some things I want to improve on, like, it still needs to retract better. I mean, it needs to retract and all, because, like, it has a hard time retracting because the pressure fills up a lot in there, and the motor, it's sort of acting as a clutch and not spinning back, so